It started with a flicker. Just a single distortion in the solar wind stream, a tiny divergence that no one noticed at first. But by the time researchers connected the dots, it was already too late to deny what the data was showing. Something was unfolding at the centre of our solar system, and it wasn't behaving like anything we had ever recorded. For the past year, all eyes have been fixed on 3i Atlas, rightly so. Its bizarre motion, unnatural reflections, and the increasing signs of intelligent design have captivated every major observatory and space agency on the planet. From Harvard to Hawaii, from deep space probes to amateur backyard telescopes, everyone has been tracking the strange interstellar object with growing concern. But something else has emerged, and it's not just near the sun, it's inside it. On the morning of December 16th, deep field sensors positioned at Lagrange Point 1, designed to monitor coronal mass ejections and solar flare activity, picked up an unprecedented series of fluctuations. Not a flare, not a burst, not even a gamma wave. This was something else. It came in pulses, perfectly timed, evenly spaced, and most disturbingly, it was emanating from a fixed location within the solar envelope, just beneath the corona. Solar plasma does not behave like that. It is chaotic, fluid, ever-changing. This wasn't chaos. This was a signal. Scientists tried to rationalize it. Maybe it was a new type of sunspot. Maybe a rare electromagnetic resonance. Maybe something ejected from 3i Atlas that had somehow looped into orbit and drifted too close to the sun. But the truth was simpler, and far more terrifying. This had nothing to do with 3i Atlas. In fact, by every measurable standard, this event made 3i Atlas look like a minor footnote. The frequencies detected weren't random. They were organized. And when overlaid against older records from the SOHO and Parker Solar Probe missions, they formed a pattern, a repeating harmonic, the kind you don't find in nature, the kind that only machines make. Suddenly the scientific community split into two camps. One believed this was a natural event with misunderstood physics, perhaps a new solar mechanism, a fusion-based anomaly we simply hadn't seen before. A warning, yes, but still explainable within the framework of known science. The other camp didn't agree. To them the signals were too perfect, the echoes too consistent, and worst of all, the timing lined up with an orbital event that wasn't supposed to happen for another 6 months. Something was early. Something had arrived. The same morning, solar imaging satellites began capturing distortions in the light patterns emerging from that region of the corona. The brightness wasn't increasing. It was bending, refracting, warping, as if something invisible was holding position just beneath the solar surface, redirecting energy, not dissipating it, not consuming it, redirecting it. That one word would change the narrative, because redirection implies choice, and choice implies intention. And intention, especially at a solar scale, forces one terrifying question to the front of every conversation. Who, or what, is behind it? In this video, we're going to walk you through every frame, every signature, and every unexplained data point that led to this moment. We'll show you why this solar event is unlike anything humanity has ever witnessed, and why even the most skeptical voices are beginning to question if something is living or operating inside our sun. This isn't science fiction. It's solar physics, particle behavior, and hard telemetry. And if you thought 3i Atlas was strange, you're not ready for what's about to unfold. On the morning of December 16th, the silence broke. What began as an ordinary solar monitoring cycle ended in a series of readings that forced every observatory to stop, recalculate, and stare. Because what the sun just did makes the 3i Atlas anomaly look like a footnote. This time, it wasn't a comet misbehaving near the sun. This time, the sun itself has changed. The object we tracked for months, 3i Atlas, challenged our models, but it didn't break the sun. What we are now seeing in the heliophysics data isn't just powerful, it's structured, it's timed, and it's something we've never recorded before. Today we follow that story, and the more you hear, the more 3i Atlas starts to feel like the warning we ignored. It started with silence. Every major solar observatory, from the Solar Dynamics Observatory above Earth to the Parker Solar Probe deep within the inner solar system, was watching the sun like they always do. Constantly, carefully, habitually. The system was stable. Readings across the board were ordinary. The sun was active, but not unusually so. There were no alerts, no warnings, no anticipation of anything anomalous. And then, at 4:32 UTC on the morning of December 16th, everything changed. A single pulse. It wasn't a solar flare. It wasn't a coronal mass ejection. It wasn't any of the usual explosive phenomena we associate with the sun's violent moods. What occurred was far more elusive and far more troubling. A uniform, radiant pulse of energy emerged from the midline of the solar disk and travelled outward at nearly light speed. Observatories that had been calibrated to detect high-energy particles, magnetic field fluctuations and X-ray emissions all recorded the same thing: a sharp, sudden spike in output across multiple wavelengths, followed by an immediate return to baseline. No chaotic decay, no turbulence, no flare loop, just a perfect burst, and then nothing. It lasted 5 minutes. Across NASA, ESA and JAXA networks, data analysts stared at their monitors, blinking in disbelief. Normally, when the sun releases energy, it does so asymmetrically. Sunspots twist magnetic fields. Loops of plasma erupt into the corona. There's direction. But it's chaotic. This wasn't. The pulse emerged almost equally across the solar equator. It was spherical, symmetric, and timed to near perfection. Not even the most balanced flares of the last solar maximum came close to this level of radial harmony. And that's what made it terrifying, because there was no trigger, no prior magnetic build-up, no sunspot activity near the epicenter, no visible signs in the hours leading up to the event. It simply began. It was as if the sun, for reasons no model could explain, decided to emit a perfectly tuned frequency of energy, and then stopped, all without disturbing any of its usual behavior. Solar physicists have a term for this kind of moment: decoupled discharge. It refers to energy being released without a clear precursor, and it almost never happens. When it does, it's usually during extreme stellar activity in distant stars far beyond our system. To see it here, on our own sun, in real time, was unprecedented. But the strangeness didn't stop at symmetry. Instruments on Stereo A, orbiting the sun at a wide angle from Earth's perspective, picked up something even stranger. The pulse appeared to bounce, or reflect, off the solar interior. Within 2 minutes of the initial release, a second wave was detected on the sun's far side, propagating in an almost identical curve. Except this time it was fainter, cooler, and delayed. Scientists quickly ruled out typical reflection. The sun isn't a mirror. Plasma doesn't echo energy like that. So the only remaining hypothesis was darker. Something on the far side of the sun had received the pulse and generated a secondary emission. This was no flare. This was no ejection. This was something new, something structured. And for many of the solar researchers involved, it was the first time in their careers they had to write the words "unclassified event" in an official report. Not because it was military, but because science didn't have a box to put it in. What came next would challenge everything, because this wasn't just a solar hiccup, it was a message, or a reaction. And 3I Atlas, the anomaly we thought we left behind, was about to be tied back into the centre of it all. Roughly 14 minutes after the initial solar pulse, the anomaly deepened. While Earth-based observatories reviewed their data and double-checked calibration systems, another signal came in, this time from the opposite side of the sun. It was unexpected, unexplained, and entirely impossible, because what was recorded didn't originate from the front-facing hemisphere of our star. It emerged from the sun's hidden half, the far side invisible from Earth. Stereo A, the Solar Terrestrial Relations Observatory positioned in a heliocentric orbit trailing Earth, had a unique vantage point. It wasn't looking directly at the sun's pulse center, but it was close enough to observe what came after. And what it saw defied every established thermal, magnetic and gravitational model we have. It detected radiation, high-frequency emissions that bore no resemblance to a typical solar echo. In gamma wavelengths, the signature was sharp and narrow. That's the opposite of what normally happens in the sun's chaotic environment. Flares produce broad-spectrum chaos. Coronal events cause scattering. But this was clean. A needle of intensity that surged and then vanished lasting no more than 3 seconds. The pulse didn't behave like a mirror reflection, nor like a delayed emission from the original event. It was distinct, separate, and worse. It came from a zone with no active sunspots, no magnetic buildup, and no visible mass ejection. Scientists were stunned, because to produce that kind of radiation on the far side of the sun, there had to be a reaction to something, and with no visible solar activity in that region, the implication was either structural, something internal within the sun's deeper layers, or external. Something had passed through, triggered, or interacted with the solar mass itself from the far side. The European Space Agency's solar orbiter offered a second confirmation. While not positioned for a direct view, its instruments detected a transient magnetic reversal. This wasn't a flare signature, it wasn't plasma turbulence, it was more like a fingerprint, a tight, compressed flux rope that twisted briefly and then dissolved. That kind of event usually occurs when something enters the solar atmosphere at high velocity, not when it leaves. But nothing had entered, at least nothing we could see, and then came the ionospheric response on Earth. 15 minutes after the second spike, the ionosphere, Earth's thin upper shield of charged particle, briefly contracted. Not by much, just enough to cause a detectable shift in long-distance radio propagation. Air traffic controllers in the southern hemisphere lost high-frequency communication for 12 seconds. Most never noticed. But the observatories noticed. They triangulated the disturbance, calculated the magnetic arrival vector and traced it, straight to the sun's far side. It was a straight-line chain reaction. Solar pulse, then radiation spike from behind the sun, then Earth's magnetic echo. But the key problem was this. The timing made no sense. The pulse and the spike were too close together to be cause and effect in traditional terms. And yet they were too precise to be a coincidence. And that's when the whispers started. What if the pulse wasn't spontaneous? What if it was provoked? And more specifically, what if something used the sun's far side to do it? That region is constantly monitored by helioseismology, the study of solar quakes and internal waves. But this event didn't appear as a ripple. It appeared as a flash. And flashes don't come from pressure. They come from energy release, controlled energy. The working theory, quietly shared among a few research teams, was chilling. Something interacted with the sun, and unlike 3i Atlas, which merely danced around the edges, this time it went deeper. Not just near the sun, but through it. As the reverberations of the solar pulse continued to echo outward, Earth itself began to respond, subtly at first, then unmistakably. Roughly 90 minutes after the dual solar emissions, Earth's magnetosphere, the invisible shield of magnetic energy that protects the planet from high-energy particles, contracted. It didn't collapse, it didn't shatter, but it shrunk by just under 3%. That number may seem small, but in space weather physics, it's seismic. The magnetosphere is Earth's outer armor. It stretches tens of thousands of kilometers into space, forming a bubble that deflects the solar wind. Its size fluctuates depending on solar conditions. During strong geomagnetic storms, it can compress slightly. But what happened on the morning of December 16th didn't follow any known solar storm model, because there was no flare, no coronal mass ejection, no solar wind surge, and yet Earth responded. Satellites in geosynchronous orbit were the first to detect the change. Several communications satellites, particularly those hovering above the equator, recorded subtle trajectory drift. Their station-keeping systems corrected automatically. No alerts were issued. But their onboard magnetometers told a deeper story. The field around Earth was pulsing, tightening, bending inward as though it had been touched by something invisible. The Van Allen belts, two massive regions of charged particles trapped by Earth's magnetic field, shifted too. Not by much, but enough to register on every radiation monitor on board the GOES weather satellites. The inner belt constricted. The outer belt tilted toward the night side of the planet. A redistribution of radiation, quiet, precise, coordinated. The NOAA Space Weather Prediction Center issued a Level 1 advisory, citing unusual magnetospheric compression. It was a technical phrase, one that few outside the field even noticed. But inside classified briefing rooms it caused alarm. Why? Because nothing in the sun's recorded output explained the compression. The solar wind speed hadn't changed. The interplanetary magnetic field remained calm. The geomagnetic indices were low, and yet Earth had behaved as if it had been struck by a pulse of enormous energy. Across radio bands, atmospheric physicists noticed something else. Shortwave propagation patterns became erratic. Transmissions that normally skip across the ionosphere suddenly died mid-path. Polar regions lost transmission capability for nearly 90 seconds. Airline routes crossing the Arctic Circle were advised to switch to satellite relays. No immediate danger, just unpredictability. Researchers at the University of Tromsø in Norway, monitoring auroral currents, logged a brief flicker, an almost imperceptible shift in the electrojet that usually dances around the poles. It wasn't caused by a flare, and it wasn't accompanied by aurora. It was a magnetic ripple, with no driver. For Earth to shrink its magnetic shield in the absence of normal space weather drivers, something else had to have been involved. And that's where the puzzle sharpened. The compression wasn't random. It matched the timing of the far side pulse from the Sun, down to the minute. In other words, it behaved like a response, a delayed consequence of something that had already happened near the Sun, but didn't radiate outward in the usual electromagnetic blast. This was targeted, focused, like a wave that didn't spread, but aimed. And more unnerving was the spatial precision. The compression began on the sun-facing side of Earth, but quickly bled toward the night hemisphere. It wasn't atmospheric, it wasn't thermal, it was magnetic, like Earth's field had been briefly shaped, sculpted by an external hand. Several models were run, none of them matched the data, because no flare had occurred, no radiation storm, no solar storm, no CME. And still, Earth had bowed. The only thing left was to ask, if this wasn't a natural event, what was it? And more importantly, who else noticed? In the hours after the solar pulse, as observatories across the globe scrambled to interpret their data, one team quietly noticed something no one else had yet mentioned. It wasn't the energy output, it wasn't the timing, it wasn't even the radiation pattern, it was the shape. The Solar Orbiter, a European Space Agency mission orbiting close to the Sun, had been recording high, resolution extreme ultraviolet imagery of the Sun's surface in near real time. When scientists began examining the raw frames surrounding the event, they found something startling buried inside the first 5 minutes of the pulse. It wasn't noise, it wasn't a lens artifact, it was structure. At the very center of the pulse, captured in ultraviolet wavelengths far outside human vision, appeared a defined geometric pattern. Not random turbulence, not chaotic flare plasma, but a rotating hexagonal filament, symmetrical, stable, and unlike anything previously documented. The initial assumption was software error. Geometry like this doesn't occur naturally in plasma flows. Not on this scale, and certainly not in the unrelenting energy of the Sun's upper atmosphere. But a reanalysis of the onboard imaging hardware confirmed it. The hexagonal structure was real. It formed quickly, within 6 seconds of the pulse ignition, and maintained coherence for nearly 40 seconds before dissolving back into ordinary coronal motion. What made this so disturbing wasn't just its shape, but its behavior. It spun against the known solar rotation. While the Sun itself rotates east to west across the sky, from our perspective, this structure spun west to east, counter-rotation. That alone defies standard solar dynamics. Magnetic filaments don't behave this way. Plasma loops don't self-orient with geometric precision. And yet, this did, and there was more. Inside the hexagon, researchers noticed fainter internal patterns, thin plasma strands forming near-symmetrical nodes, connected by what appeared to be radial flickers, blinking in and out of visibility. Initially dismissed as turbulence, the flickers turned out to have consistent spacing and timing, exactly 0.2 seconds apart. That interval is critical, because it matches the harmonic resonance frequencies found in experimental fusion reactors on Earth, tokamaks, where magnetic confinement is used to control high-energy plasma in stable shapes. In those machines, similar frequencies are used to maintain containment fields. The idea that a naturally occurring structure on the Sun could display the same timing intervals is statistically implausible. It suggests that something inside the pulse was behaving as a controlled system, not radiating, not exploding, not flaring, rotating. The plasma didn't scatter chaotically outward like in a typical ejection. It arced, curved, bent, like it was being shaped from within, like it was responding to a magnetic scaffold. And when the pulse ended, it didn't dissipate in bursts, it faded as one. At NASA's Goddard Space Flight Center, a separate team ran magnetic field reconstructions based on available data. The 3D modelling revealed something else. For the duration of the pulse, a toroidal loop, a donut-shaped magnetic feature, briefly formed around the filament zone, then vanished. This is unheard of in solar physics. Toroidal loops do exist, but only in laboratory-scale plasma experiments. On the Sun, magnetic loops are sprawling, arcing, sunspot-bound structures. This was tight, contained, and centered precisely over the hexagonal pattern. That symmetry sent a shiver through the astrophysics community. Because symmetry implies planning. It implies intentionality. And the deeper you dive into the data, the less it looks like a flare, and more like a device, a brief presence, a system activating, or perhaps reacting. Was it internal? Was it foreign? No one could answer, but what they now knew was this. The Sun had just formed something impossible, not a flare, not a burst, a shape, and it had lasted just long enough to be noticed by those paying very, very close attention. At first, it seemed unrelated. The strange pulse, the symmetrical shape, the magnetospheric reaction. Every agency was focused on the Sun, rightly so. But as teams began mapping the solar system's geometry on the morning of December 16th, one observation changed the focus. 3 days earlier, on December the 14th, 3 Atlas had passed behind the Sun, from Earth's perspective. It was out of sight, inaccessible to optical telescopes. Its last observed trajectory showed it continuing outbound, following its hyperbolic escape path back toward interstellar space. It was supposed to be gone, and yet it wasn't. ESA's solar orbiter, positioned with a wider angle on the solar disk, had continued tracking 3I Atlas as it slipped into the far side shadow. It wasn't the primary focus of observation, it was routine orbital maintenance. But those background position logs, those faint low-resolution thermal plots, suddenly became critically important. Because when overlaid with the centre of the pulse, when the coordinates of the pulse's geometric centre were plotted over the Sun's visible hemisphere, 3I Atlas's predicted position sat directly behind it. Not near, not close, exactly aligned. That changed everything. It's easy to dismiss coincidences in space. The solar system is vast. Alignments happen. But this wasn't a simple line-of-sight overlap. This was a 3-dimensional vector alignment across time, energy, and position. The object that had spent months misbehaving near the Sun, defying outgassing models, reflecting like a mirror, resisting physics, was now perfectly positioned behind the origin point of the most structured solar event ever recorded. This couldn't be ignored. Astronomers dug back through the data, and they began to see the patterns all over again. In late October, 3I Atlas had flared briefly near the Sun, and then accelerated in ways that violated standard cometary behaviour. Not wildly, but smoothly, in rhythm with a solar storm. It had spun against radiation pressure, emitted non-thermal signatures, and shown signs of artificial reflection, polarization curves that matched manufactured surfaces more than comet dust. And now, 3 days after its final visual confirmation, a solar pulse appeared, originating from the exact spatial region 3I Atlas had entered. Some researchers proposed the obvious explanation. The object had disintegrated. Perhaps the heat had finally overtaken it. A final ejection. A burst of reflective material triggering the solar pulse. That would be a neat answer, but it didn't hold, because the thermal data from the far side showed no debris, no dust cloud, no gas emissions. The zone where 3I Atlas should have exploded remained silent, cool, empty, as if it had simply ceased to exist, or had gone somewhere. Some at ESA began calling the phenomenon a transit shadow, not an explosion, not an emission, but a temporary signature in the solar electromagnetic field that behaved as if something moved through the Sun, not across it, not near it, but through the photosphere itself. The word tunnelling appeared in one internal memo, not as a literal concept, but as an analogy, something that slipped between states, one moment visible, the next absorbed, And still, the timing matched. The solar pulse began 3 days after 3i Atlas disappeared, as if the sun wasn't just reacting to its presence, as if it was responding to something it had encountered, something that had returned. It was no longer about whether 3i Atlas was a comet, a probe, or a natural wanderer. It was about what it had left behind, because now the sun was different. And every telescope aimed skyward had begun to realize, whatever 3i Atlas was, it wasn't finished. As the post-pulse data poured in, one pattern began to crystallize. Quiet at first, almost buried in the background noise, but growing louder with each layer of analysis. It wasn't a flare, it wasn't thermal, it wasn't visual, it was frequency. Specifically, the sun had started to emit a repeating electromagnetic pattern. The signature was faint, buried in the background solar emissions, but it was there. A sequence of low-frequency pulses spaced precisely 0.99 seconds apart. Too regular to be random, too structured to be background interference. Parker Solar Probe was the first to catch it. Orbiting deep inside the sun's inner heliosphere, the spacecraft continuously monitors solar plasma, radiation, and field activity. In the hours after the December 17th pulse, its onboard instruments picked up a subtle rhythm, like a soft metronome ticking beneath the roar of solar noise. At first, it was dismissed. Artifacts, signal bleed, spacecraft harmonics, all plausible. But then Stereo A recorded the same signal. So did the Japanese Hinode mission, so did NASA's wind probe stationed at Lagrange Point 1. 4 separate observatories, all reporting the exact same pulse rate, all located at different positions in the solar system. That's when researchers started calling it what it was, a lock. Because the pulse rate, 0.19 seconds, was not arbitrary. It matched another object, one already well known to the solar system, 3i Atlas. Before it disappeared behind the sun, 3i Atlas had exhibited a rotational signature in the light curve data, faint fluctuations in brightness caused by spinning or tumbling. The rotation period? Just under 0.99 seconds per full rotation. At the time, it had been treated as unusual, fast, but not impossible. Now, in light of the solar rhythm, that detail changed everything. The sun was mimicking it. Or the object was still broadcasting. Or, most unsettling of all, they were resonating. A resonance implies 2 things: structure and interaction. In physics, when one body vibrates at a frequency that matches another, the energy builds. That's how bridges collapse in windstorms. That's how glass breaks from sound. And in space? That's how signal can emerge from silence. The idea of a frequency lock between a star and an object orbiting nearby, let alone an interstellar object, is unprecedented. Our sun has never exhibited this kind of electromagnetic coupling with anything. Not Mercury, not Earth, not even Jupiter, whose massive magnetic field interacts with solar wind on colossal scales. But this was different, because the signal didn't vary. It didn't drift. It held perfectly for over 90 minutes, before vanishing mid-cycle as if the communication had been terminated. Scientists debated the source. Could it have been solar machinery, interference from the pulse, internal magnetic feedback? But one fact silenced every alternate theory. The frequency lock only began after 3i Atlas passed behind the sun, and it ended precisely when Earth's magnetosphere returned to normal, as if the moment of synchronization was both cause and effect, something activating the field between them, and then releasing it. Some at ESA referred to it as a harmonic bridge. Others, more cautiously, called it a transient electromagnetic entanglement. But one team at the Max Planck Institute said it plainly: "We're observing a conversation. We just don't know who's speaking." The idea that an object could lock frequencies with the sun, a billion-degree thermonuclear sphere of plasma, isn't just provocative, it's impossible, unless the object had some kind of responsive system, or unless the sun was responding to the object, and if that's the case, then 3i Atlas was never just a visitor, it was a participant, and the sun, for the first time in recorded history, answered. Not all anomalies are about violence, some are about absence, the moments when something expected fails to appear, and in the case of the December 17th pulse, what was missing turned out to be just as significant as what was released. Because while the pulse radiated energy in every measurable direction, light, magnetism, particles, Something strange was happening at the surface level of the sun itself. There was a drop, a measurable dip in temperature, localized, temporary, and completely unexplained. It was first spotted by NASA's Solar Dynamics Observatory, which measures the sun's photosphere using visible and infrared light. During the pulse's 5-minute duration, a specific region near the equator dimmed in infrared, indicating a drop of nearly 4% in apparent surface temperature. This is not subtle. The sun doesn't just cool in zones like this. The photosphere is driven by continuous nuclear fusion. Surface convection is violent, chaotic, and relentless. And yet this zone, precisely where the pulse originated, dimmed and cooled. It was as if something absorbed energy from the sun's surface. Now, localized cooling can happen during sunspot formation, but that's tied to magnetic field disruptions. In this case, no magnetic loops were present. No sunspot existed in the zone before, during, or after. In fact, this region had been magnetically quiet for weeks. There was no build-up, no flux emergence, no plasma arc. The cooling came from nowhere and ended just as suddenly as it began. The temperature normalized within seconds after the pulse faded. At the European Southern Observatory, thermal reconstructions showed that the heat loss pattern was not radial, as in flares or CMEs, but angular, narrow, conical, and slightly offset toward the solar limb. That's not how heat dissipates in solar physics. Heat should radiate outward. This looked directional, like something had either drawn energy into itself or blocked it from escaping. In other words, this wasn't a burn, it was a drain. Several hypotheses were proposed. Maybe a magnetic flux rope had briefly trapped heat. Maybe a sudden pressure drop had altered energy transmission, but none of these matched the real-time pressure or magnetogram readings. The energy didn't move, it simply vanished. That left one possibility: absorption. Absorption is a term we rarely use in relation to the sun. The sun emits, the sun radiates, the sun blasts. Nothing absorbs from it, certainly not in defined zones. But this time, it seemed something had reached in, taken a bite of the sun's heat, and left without a trace. And then someone noticed something else. The pattern of heat absorption, down to the geometry and timing, matched a thermal model run just 2 months earlier. The object in that model? 3I Atlas. When the object had passed near perihelion in late October, its infrared profile had suggested that it was absorbing solar radiation at a higher efficiency than its mass and composition should allow. At the time, it was written off as an artifact of rotation or surface composition, but now the sun itself was mimicking that same absorption curve. Which raised the most uncomfortable question yet. Was the sun copying 3I Atlas? Or was something using the same energy harvesting mechanism? The notion that a solar zone could be selectively cooled, without internal cause, without magnetic deformation, without plasma eruption, implies intervention, or technology, or both. And if something did absorb energy from the sun, then that something was either still nearby, or it had already moved on, charged and ready for whatever came next. By the time Earth's observatories had fully absorbed the implications of the pulse, new reports began surfacing, this time from a different type of sensor. Amateur radio operators scattered across Asia and the Pacific began noticing something odd during the event window. Their transmissions, on shortwave, VHF, and UHF bands, went silent. Not scrambled, not distorted, just gone. Complete blackouts lasting from 30 seconds to 3 minutes, depending on location. Initially, it was assumed to be routine atmospheric disruption. Space weather can do that. But there was a problem. The blackout wasn't random. It wasn't global. It was targeted, confined to a single transmission angle that traced a very specific path through the ionosphere. When triangulated, the dead zone pointed not to a flare region, not to a local geomagnetic storm, but to a single vector in space. A narrow corridor aligned directly with the sun's equator, the same latitude where the pulse had originated. And this blackout wasn't limited to amateur frequencies. Military radar installations in India, Japan, and Australia recorded cone silence, a sudden loss of radar return in a narrow directional band. Planes continued to function. Satellites continued to transmit. But any radio signal sent through that spaceward vector disappeared. It was as if something had created a temporary shield. a curtain that absorbed or deflected all radio signals along a precise axis. But that's not how the sun works. Solar interference usually scrambles frequencies, it adds noise, it overwhelms systems with signal, not erases them. This was a blackout not caused by atmospheric density, not by solar burst, but by interference that removed the signal completely. Radio scientists called it a directional null, but behind closed doors many used a different term, eclipse, because what it behaved like was an object, an invisible body large enough and dense enough to block Earth's outbound signals across multiple frequencies, yet it left no visual trail, no IR signature, no reflected sunlight. Whatever it was, it had mass, but no light. And the duration of the blackout when plotted across stations and angles formed a slow sweep, as if an object had passed through the line of sight arc from Earth to the sun, just as the pulse ended. The implication? Something was between us and the source, not the sun, not the object, but a third party, and it had moved in, blocked our sight, and left. No damage, no heat, no sound, only silence, just long enough to go unnoticed, unless you were watching for it. And now, someone was. Not just in visible light or ultraviolet bursts, but in the highest energy regions of the spectrum, X-rays. NASA's GOES satellites have been measuring these solar X-ray fluxes for decades, tracking every minor fluctuation, spike, or flare. But the pulse that erupted on December 17th didn't fit. At first glance, there was an X-ray spike. It registered as a mid-class flare, brief, sharp, and intense. But when researchers overlaid the flux profile with typical flare signatures, something disturbing emerged. It was too clean. Solar X-ray bursts normally show a chaotic waveform, sharp peaks and uneven decay, driven by random reconnections in the solar magnetic field. This one had symmetry, a perfect bell curve. Rise time and fall time were mirror images, each 128.6 seconds in duration. The curve wasn't just smooth, it was engineered. Researchers at the Max Planck Institute ran a waveform decomposition using Fourier analysis, expecting to find the typical broad harmonic noise of solar events. Instead, they found discrete frequency peaks, regular, harmonically spaced, with almost zero variance. That kind of structure doesn't exist in nature, not at these energies, not in solar physics. This wasn't a burst from chaotic plasma. It was a signal, and it gets worse. When the waveform was compared to human-engineered energy pulses, like radar, LIDAR, and certain classified ionospheric heaters, it showed overlap in pattern. The pulse matched what's called a coherent phase emission. That's something we use in directed energy technologies, phased array radar systems, and, according to some declassified DARPA papers, experimental space-based power transmissions. In other words, this X-ray event didn't leak energy, it delivered it. To what, or from what, no one could confirm. But the consequences were immediate. Earth's upper ionosphere expanded by several kilometers in the wake of the burst, as if superheated by something far more directional than a flare. And it wasn't just cues that caught it. Japan's Hinode telescope, tuned to high-resolution X-ray imaging, recorded a peculiar ring pattern, a concentric shock that expanded from the origin point like a ripple. Except it wasn't circular, it was hexagonal. Yes, hexagonal symmetry in an X-ray flare. Solar physicists went into panic mode. Theories were thrown around, standing magnetic waves, resonant lattice effects, unknown plasma shell geometry. But the symmetry was too precise, too consistent across wavelengths, too artificial. It looked like something had been injected into the solar atmosphere. And some began asking a forbidden question. Had something inside the sun just fired a directed X-ray beam? On purpose? The alignment with Earth, the coherent waveform, the symmetric flare profile? It didn't read like natural physics. It read like a system, a delivery system, an emission protocol. Even more concerning, the amplitude matched energy densities used in known propulsion systems, if scaled up by orders of magnitude. Which meant one terrifying thing. If this pulse was not a natural flare, then something had just used the sun as an amplifier, a natural nuclear reactor turned into a broadcasting station, and no one could say whether it was meant for us, or if we just happened to be standing in the path. While all attention was focused on the pulse from the sun, another silence was forming, not in sound, not in radiation, but in data, specifically from the tail of 3I Atlas. Since its perihelion encounter with the Sun, astronomers had been closely monitoring its massive tail, which had grown to over 2 million kilometers in length. Its dust particles, gas plumes, and plasma interactions were expected to show variability, just like any active comet under solar stress. But in the aftermath of the pulse, that tail went quiet, spectroscopically quiet. NASA's IRIS and ESA's solar orbiter both recorded spectral returns from the tail that suddenly dropped in signal variance. The chemical signatures, normally rich in carbon monoxide, cyanogen, water vapor, silicates, flatlined, not in intensity, but in diversity. Instead of showing a spectrum full of spikes and dips indicating ongoing material release, the return became uniform, like it was reflecting only a narrow band of frequencies. More than one analyst compared it to a mirror. But comets are not mirrors. Their tails are chaotic messes of sublimating material, constantly reacting to solar wind, photon pressure, and magnetic entanglement. You don't get uniform spectra from that, unless the tail had stopped emitting and started filtering. In other words, the comet's tail, formerly a random cloud of debris, had become a surface, a functional layer that was reflecting solar radiation in a narrow band, while absorbing or cancelling everything else. That's not just anomalous, that's design. Theories again flew. Maybe the tail had ionized completely, or maybe it had collapsed magnetically. But magnetometers showed no field change, and the brightness didn't drop, it actually increased. One observatory in Chile noticed something even stranger. The tail's brightness oscillated rhythmically at a frequency of 0.012 Hz. That's not a natural solar rhythm, that's a mechanical beat, once every 833 seconds. Not only was the tail not evaporating as expected, it seemed to be cohering into something structured. And if the tail was no longer the result of decay, but the product of construction, then everything about 3I Atlas changed. It wasn't just a comet anymore, it was a platform. One that had just gone silent in the spectrum, possibly because it no longer needed to speak in light. It had entered a new phase, one that the solar pulse may have triggered or confirmed. At first, the shadow didn't look unusual, just a standard solar transit. 3I Atlas moving between Earth's orbit and the outer corona, casting a dim crescent across extreme ultraviolet imaging. But on the morning of December 17th, researchers at the Solar Dynamics Observatory noticed something deeply wrong. The shape was wrong. Objects in space cast predictable shadows, shaped by their geometry and the angle of incident light. Comets, even massive ones like 3I Atlas, throw uneven blotches, soft-edged, evolving contours. But this time, the shadow cast by Atlas wasn't fuzzy or irregular, it was angular. At precisely 0817 UTC, a frame captured during a full-disk corona scan revealed an outline that made scientists halt their routine analysis. The object blocking a segment of the solar corona didn't resemble a dusty nucleus or outgassing tail. It resembled a triangle. Not just a triangle, a perfect equilateral one with sharp boundaries and symmetrical proportions. The data team reprocessed the raw imagery, suspecting calibration errors. But frame after frame confirmed the same geometry. The edges held. The rotation matched no known tumbling pattern. The triangle held position for 3 full minutes before fading into the corona's glare. That shouldn't be possible. The prevailing theories broke immediately. No known comet structure, even one undergoing fragmentation or sublimation, could maintain a stable triangular occlusion, especially one this precise. Solar radiation, drag, and tail dynamics would all deform such a shape, unless the shape wasn't incidental, unless it was intentional, and if it was intentional, it might not be part of the comet at all. Speculation exploded in closed astrophysics forums. Could this be a shadow not of Atlas itself, but of something attached to it? Or worse, something moving in tandem behind it? The team from ESA's Proba 2 satellite reanalyzed EUV sequences from earlier that morning. Faint, almost imperceptible shifts in the field density hinted at layered occlusion, like two objects moving in sync, one masking the other, but not entirely. The larger question began to form. Had Atlas become an anchor for something else? If the shadow belonged to a triangular craft, That meant it was absorbing light in specific wavelengths. Instruments looking for heat signatures found none. This thing was cold, or actively shielding thermal output. That's not just stealth, that's cloaking. And the triangle wasn't alone. Later models running light curve analysis backward through several weeks of Atlas transit data revealed a repeating secondary dip, a smaller, faster object consistently following the same orbital arc, like a drone escort or probe. And it matched the same geometry, 3 edges, 3 angles, 3 seconds of silence from the analysts when the shape first appeared. But that was enough to fracture the comet narrative completely. Because shadows don't lie, and when geometry defies physics, only one explanation remains. Something intelligent is shaping it, and it's getting closer. Orbital dynamics are among the most predictable aspects of celestial mechanics. Once an object is on a trajectory through the solar system, its future path can be modelled with exquisite precision, unless an external force interferes. That's what made the December 17th data so shocking. 3i Atlas, still under active monitoring by observatories worldwide, had begun a measurable drift in its trajectory weeks prior. Nothing unusual. Comets are affected by solar radiation, asymmetric outgassing, and gravitational nudges from nearby planets. But in the early hours of that morning, the drift didn't accelerate, it reversed. When the data first arrived at the minor planet center, it was flagged as anomalous. The object's velocity vector had changed direction against the influence of gravity. At 0312 UTC, a subtle deceleration was recorded. By 0317, a redirection began, curling the trajectory not around the Sun, but slightly away from it, something not even the strongest jet outburst could cause, unless it was purposefully timed and directed. Within 30 minutes, it was clear. 3i Atlas had reversed its orbital drift by approximately 7 degrees off course. That doesn't happen by chance. The sheer energy required to alter the course of an object that size is staggering. This isn't a spacecraft executing a mid-course correction. This is a comet-like body, potentially hundreds of meters wide, responding as if under guidance. Astronomers scrambled to explain the shift. Was it a collision? No debris. Was it sublimation? No corresponding thermal spike. Was it a magnetic interaction? The field lines showed no deflection. And then came the realization. The motion wasn't random, it was calculating. When models were recalculated using the revised heading, the new course didn't send Atlas spiraling out into space, it curved it closer to Earth. But this wasn't a collision trajectory, it was a flyby arc, a maneuver often used by spacecraft to gain velocity or reorient toward a target. And this wasn't the first time. Historical drift patterns from October and November showed smaller reversals, too minor to be noticed in real time, but clear in hindsight. Each time, the object course-corrected as if avoiding detection or aligning with something deeper in space, or perhaps with something on Earth. It was now behaving like a scout. The implications sent shockwaves across the solar observation network. Was this object adjusting based on feedback? Did it have external control? Was the triangle shadow part of an onboard propulsion system or something else entirely? NASA's Jet Propulsion Laboratory ran a deep field simulation and found that the new path would bring Atlas within range of several key satellites in Earth orbit during its close pass. Satellites that observe and emit microwave communication signals, satellites that could be probed or mimicked. The reversal wasn't a course correction, it was a positioning move, a chess maneuver by an object that wasn't acting alone. It was moving in anticipation of something, and whatever was guiding it didn't just understand the solar system, it understood us. Hours after the orbital drift reversal was confirmed, Earth's magnetosphere recorded something else, something that didn't originate from the Sun or from any known cosmic body. A brief but measurable electromagnetic pulse echoed across the outer layers of the planet's magnetic field. It wasn't a solar flare, it wasn't background noise, it was a clean signal. The pulse lasted only 3 seconds, but it had structure, frequency peaks, harmonic layering, and a clear envelope shape which suggested intentional modulation. Not the raw burst of natural radiation, but something filtered, something shaped. At first, ground-based instruments thought it was an error, until it repeated. 3 seconds of silence, then again and again, 5 total pulses in 20 minutes. This wasn't random, and it wasn't coming from deep space. Each echo appeared to bounce across the dayside of Earth's magnetosphere, as if reflecting off something localized and nearby, and the timing perfectly aligned with 3i Atlas's redirected arc. For the first time, observers had to ask, was this object interacting with Earth's magnetic field, not by accident but by design? The pattern bore eerie similarities to how submarines use sonar: a quick pulse, a wait for return, another pulse, each separated by a consistent delay, almost like a system scanning for density, resistance, or resonance. NASA's Deep Space Network began triangulating potential sources. Their data was cross-checked against everything from atmospheric lightning to auroral particle flows. Nothing matched. The pulse wasn't generated from Earth, but it was being responded to. Satellites orbiting in geosynchronous paths, especially those near the equator, briefly lost synchronization during the fifth pulse. One even rebooted mid-cycle. Engineers labelled it a glitch. But magnetometer data told a different story. This wasn't just a pulse, it was a probe, a test of Earth's electromagnetic boundary, a fingerprint check, like something pressing gently against the field's outer surface, mapping its contours, measuring its delay times, searching for something underneath, and more importantly, watching how we'd react. For decades, our magnetosphere has been a silent shield. It deflects solar radiation, blocks cosmic particles, and keeps our biosphere from being stripped away. But what if it's also a signature? Something that reveals our presence, not just biologically, but technologically? And what if something is listening for it? Scientists at the European Space Agency released a confidential note to collaborating agencies, never made public but later leaked to independent researchers. It suggested that the pulse echo bore similarities to electromagnetic bursts used in controlled plasma shaping. In other words, something may have understood the structure of Earth's magnetic field and may have been shaping a reaction around it. The fifth pulse was the strongest. Its tail end overlapped with an unusual microbursts of auroral activity near the Arctic Circle, an event with no solar origin and no predicted geomagnetic storm. Just light, glowing faintly in the sky, during a window that should have been calm. Light that shimmered not randomly, but in rings, and this phenomenon was seen just minutes after 3i Atlas passed the sector where the echo originated. There were no official statements, but instruments across 3 continents confirmed the same thing. Earth's magnetic field had been touched, not breached, not broken, but recognized. And now something out there knew exactly where we were and what our shield was made of. Roughly an hour after the final pulse echo was detected in the magnetosphere, space telescopes positioned along Earth's dayside began noticing something even stranger. A second object, fainter, less active, and trailing behind the main solar anomaly, had begun to fracture. But it wasn't a natural fragmentation. It wasn't random. It was geometric. Instead of breaking apart in jagged, spiraling pieces like comets often do, this object split cleanly into what could only be described as a grid, a rectangular lattice, perfectly spaced. Roughly a dozen smaller sections arranged with angular precision, like modules detaching in a controlled sequence. There were no debris clouds, no ice shrapnel, no dispersing trails. Each fragment slowed down evenly and positioned itself in near-symmetrical spacing around the original path, almost like satellites establishing formation. Some compared it to how communication constellations are deployed in Earth orbit. But this was no Earth-made technology. This was something that had been drifting silently in the wake of a solar-bound anomaly, until now. For astronomers used to the chaos of cosmic physics, this was something else entirely. Order, intention, design. The newly formed grid moved as one body. When the lead structure adjusted course, by only fractions of a degree, the rest followed, maintaining distance, maintaining alignment. Nothing flared, nothing flinched. The whole array coasted through solar radiation as if it were immune to the forces that usually scatter natural objects. Then, at precisely 14 UTC, every fragment in the grid momentarily reflected the sun's light at the same angle, causing a brief but measurable spike in optical brightness from ground-based sensors. Some took this to be a coincidence of solar flare geometry. Others weren't so sure. This event marked the first time a formation of unknown origin had been witnessed shaping itself after entering Earth's observational boundary. And it changed the nature of the discussion completely. We were no longer dealing with a rogue object. We were looking at a system, and one that had now, deliberately or not, revealed its structure to every telescope watching. It began as a whisper in the sky, barely visible, just a shimmer above the Arctic Circle. But within minutes, it transformed into a full spectacle of moving light, an aurora, in daylight. That shouldn't have been possible. Auroras are caused when solar particles slam into Earth's magnetic field, typically arriving hours after a major flare. But on the morning of December 17th, there had been no flare, no coronal mass ejection, no magnetic storm forecasted. Yet there it was, a moving veil of light dancing over Scandinavia, northern Russia and parts of Canada. And all of it happening while the sun was high in the sky. Witnesses described the aurora as more structured than usual, concentric rings, lattice patterns, and what looked like a radial pulse spreading from a single focal point above the horizon. Pilots flying over the polar routes reported navigation errors and momentary blackouts of onboard magnetic sensors. When magnetometers were checked afterward, the field hadn't spiked. It had dipped sharply and locally. Something had drawn energy away from the pole. Theories quickly emerged. Perhaps this was the result of the grid-like structure reported hours earlier. Perhaps one of the modules had triggered a magnetic coupling event. Or perhaps this was a natural consequence of the earlier pulse echoes, some kind of stored resonance finally discharging. But as the auroras faded, another question began to take shape. If light could be generated in the atmosphere without solar activity, what triggered it? And who or what was controlling the frequency? By mid-morning on December 17th, Earth's solar observatories began to converge on a growing mystery, one that even the most seasoned physicists couldn't immediately account for. The object in question, once dismissed as a minor solar ejection or perhaps a comet fragment, had entered a visibility range with enough optical detail to reveal something staggering. It wasn't emitting heat. It had no tail. And yet it was accelerating. Normally, when a comet or solar-bound object nears the sun, it begins to shed material. The solar wind blasts its icy surface, creating a tail that flares out, pointing away from the star. This tail, often glowing with ionized particles, is a classic sign of interaction with solar radiation. But this object had none of it. Infrared imaging from the Daniel K. Inouye Solar Telescope revealed that it was cold, not just low-mission cold, but nearly inert. It absorbed energy without radiating it back. There was no spectral signature consistent with vaporization, melting, or any of the common processes associated with heat buildup near the sun. Even more confusing was the trajectory. Instead of slingshotting outwards or decaying into a solar plunge, the object's path began to curve, not like a natural arc, but like a course correction. Its motion was too precise, too refined. Several physicists noted that its movement resembled orbital insertion, as if it were preparing to stabilize around a fixed solar latitude. But how? With no visible propulsion, no venting gas, and no tail. The absence of a tail meant there was no active loss of mass. The lack of heat meant it wasn't undergoing surface stress or friction against particles. It glided, silently, through a zone where most objects burn or disintegrate. Some at NASA initially theorized that the object might be shielded by some unknown coating or material. Others wondered if it was absorbing solar energy in a way that hadn't been observed before. But neither theory explained the biggest anomaly. Of all, why was it getting faster? Objects near the sun don't accelerate unless pushed, by gravity, radiation, or impact. But this object was beyond the point where gravity alone could explain its vector. And still it moved, steadily gaining speed, without any identifiable push. More troubling still was the fact that no tail meant no outgassing, which ruled out comet behavior. No heat meant no natural heating signature, which ruled out asteroid spin-up or solar melting. And yet, this object was active. The conclusion, though tentative, was chilling. This was not just a rogue object, it was something else entirely. A system of movement, acceleration, and energy absorption that operated on principles we don't yet understand. And it was getting closer to a region of space that satellites actively monitor, not just for science, but for survival. Whatever this object was, It wasn't finished revealing itself. Roughly 7 hours after the grid object fractured near the Sun and the daylight aurora faded over the Arctic, a new anomaly emerged, this time on the night side of Earth. In the vast stretch of sky above the South Pacific, multiple military-grade satellites began detecting pulses of light. But these weren't flares, and they weren't natural reflections, they were geometric. First came a triangle, 3 flashes forming the points of an equilateral pattern, blinking in sequence. Then a cross, 4 cardinal points lighting up in near-perfect symmetry. Each pulse lasted exactly 3 seconds, followed by 5 seconds of total darkness. Ground-based optical sensors in Hawaii, New Zealand and Chile confirmed the pattern. These were not artifacts or sensor glitches. The flashes were visible, barely, but real. Some thought it could be communication, though from whom, no one knew. What made this even stranger was that no radar picked up physical matter at the flash locations. No comets, no satellites, no fragments. It was as if the light came from nothing. At first, the flashes were written off as upper atmospheric phenomena, but the geometric perfection persisted, hour after hour. And then came the clincher. Several deep space telescopes caught a reflection spike off one of the pulses, suggesting that there was indeed a surface there, just one operating well below standard reflectivity or transparency thresholds. In other words, stealth. Whether it was intentional or simply beyond our detection models, something was flashing over Earth's most remote ocean in deliberate shapes, and those shapes followed geometry no natural object would spontaneously adopt. This changed everything, because for the first time it looked like Earth wasn't just being observed, it was being signalled. As the strange flashes over the South Pacific continued into the early hours, a quiet alarm triggered inside a system that very few people know exists. High above Earth, buried inside a classified electromagnetic monitoring array run jointly by several spacefaring agencies, a subtle shift in the magnetosphere was detected. But it wasn't triggered by solar wind. It wasn't from a coronal mass ejection. It wasn't even from space weather we've catalogued before. Instead, the planet's natural electromagnetic shield began forming a countershift, almost like it was reacting preemptively. The magnetosphere realigned, tightening along polar fields, while thinning around equatorial bands, and it did this before any measurable impact had occurred. This was not normal behaviour. The Earth's magnetic field typically responds after an event, a flare, a burst of radiation, a pressure wave. But this time, it adjusted itself in anticipation of something that hadn't happened yet. For the researchers monitoring it, this looked almost like predictive defense, as if the planet sensed what was coming and was preparing for it. But Earth doesn't think. Earth doesn't anticipate. At least that's what we've always believed. The energy redistribution patterns closely mirrored the theoretical simulations used to model artificial magnetic shielding in long-term space travel, projects like Mars colonization or Deep Space Station protection. This meant one of two things. Either an unknown force was manipulating the field intentionally, bending it with technology far beyond our understanding, or Earth's magnetic system is somehow more adaptive, more alive than we've ever acknowledged. Neither explanation sat comfortably with the scientific teams watching the graphs change in real time. The polar lights had vanished, but what replaced them was more mysterious. A silent reorganization of our planet's protective boundary, as if responding to an unspoken threat. Meanwhile, ground systems picked up no quake activity, no ionospheric turbulence, and no increase in solar wind. It was as if the planet wasn't responding to an external force. It was adjusting to the presence of something invisible, something already here, and nobody knew how to stop it, because we didn't know what it was. At approximately 4:20 a.m. UTC, the Solar Orbiter, ESA and NASA's Joint Solar Observation Satellite sent back data from the far side of the Sun. What it showed was not explosive, it wasn't bright, it wasn't violent, it was almost gentle. A single pulse emerged from the quiet zone, an area of the solar surface not currently facing Earth. The pulse looked like a low-frequency bulge, barely registering on typical flare charts. But it didn't behave like solar plasma. It moved like a signal. The pulse stretched across a portion of the solar surface with near-perfect symmetry, forming a ripple that travelled outward without any explosive origin point. It was soft, consistent, and clean. No scatter, no chaotic bursts, no filament tear. Its pattern resembled what some astrophysicists call coordinated resonance, the kind of movement we associate with engineered plasma fields rather than natural eruptions. And it was silent. Not silent in the vacuum sense, silent in that nothing followed it. No radiation burst, no magnetic storm, no particle wave, just a perfect, clean ring that faded as if it was never there. But the satellites watching Earth's side felt it. Magnetometers across 3 continents twitched the moment the pulse began. Even though they were watching the opposite side of the Sun, that shouldn't be possible. A weak bulge on the far side cannot cross the Sun, Earth's magnetosphere, and still make instruments react. And yet, it did. This raised a deeper question. Was the pulse coming from the Sun at all? Or had something used the Sun, like a lens or an amplifier? What we witnessed didn't match any known solar behaviour. It wasn't a CME. It wasn't a flare. It was a message. A low-frequency signature that didn't intend to damage or destroy, but to be noticed. For those who've studied deep solar harmonics, this wasn't just unprecedented, it was impossible. And yet, there it was, echoing across the electromagnetic fabric of the entire inner solar system, right before everything changed. In the hours following the pulse from the quiet side of the Sun, one region of space grew strangely active. The Lagrange point 1, known to most simply as L1. This is the spot between the Earth and the Sun where gravitational forces balance perfectly, allowing satellites to hover in relative stillness. It's where SOHO, DSCOV, and a handful of classified platforms sit, watching for incoming threats. At 5:02 am UTC, as systems stabilized and magnetometers reset after the pulse, SOHO's coronagraph captured a frame that immediately triggered a Tier 2 alert inside NASA's Solar Watch division. A black silhouette had appeared. Not debris, not an asteroid. A symmetrical, solid shadow, positioned exactly where no known object should be. It wasn't moving fast. In fact, it wasn't moving at all, at least not in the way natural objects do. It held position at L1, absorbing solar light from behind and creating a perfect circular eclipse, like an artificial eye staring directly at Earth. The strangest part was its shape. This wasn't some chaotic rock or tumbling metallic junk. The edges were smooth, curved but not spherical. It was concave, like the interior of a parabolic dish or an ancient satellite dish scaled up to incomprehensible size. For 11 minutes the object remained in perfect balance, casting no flare, no heat, no backscatter. Some systems couldn't detect it at all. It was almost as if it only existed in certain wavelengths, visible in polarized light, but completely absent in infrared and radio bands. The scientists scrambled to cross-check other observation points. DSCOV's instruments picked up a local disturbance in solar wind pressure, but nothing visible. The James Webb Space Telescope aimed elsewhere showed nothing unusual from its own station at L2, and then the signal came back, the one that had vanished during the South Pacific Sky event. At precisely 5:13 am, a faint but measurable frequency envelope returned to deep space receivers, originating from exactly where the silhouette had appeared. This wasn't background noise, it was structured, repeating in a pattern that matched no known natural sequence, no pulse or rhythm, no black hole flicker. It wasn't loud, it wasn't fast, but it was persistent, and it was aimed, not at Earth, but at something behind us, as if it had bypassed Earth entirely, and was trying to reach something already past us. The hypothesis was immediate and controversial. What if the structure wasn't a threat to Earth at all? What if it was a relay, a kind of way station, built not to transmit but to receive? And worse, what if the solar event we were watching unfold wasn't just solar? What if it was engineered? That question tore through every space agency boardroom in less than 20 minutes. Private intelligence satellites were redirected. Corporate space firms went dark on their tracking logs, and inside mission control rooms around the world the same quiet realization crept in. Something at L1 had opened its eyes, and Earth was no longer alone in watching the Sun. Less than 30 minutes after the silhouette vanished from L1, something even more peculiar began to ripple through the data streams. A silent disappearance, not of light or matter, but of a specific particle that solar physicists rarely talk about publicly. Helium-3. It's an isotope, an ultralight form of helium created in the nuclear fusion process deep inside the Sun. Normally it drifts outward in solar wind, invisible to the eye but detectable with the right instruments. For decades, space agencies and private mining ventures have eyed helium-3 as the holy grail of clean energy. Its presence on the Moon, on comets, and in the solar stream is traceable, predictable, stable, until now. At 5:42 a.m. UTC, an automated alert triggered from Lunar Pole 9, a helium-3 detection platform orbiting the Moon's far side. Every hour it samples the solar wind, tracking the concentration of particles flowing toward the lunar surface. This time, the sensors showed something strange, a 98% drop in helium-3 flux. At first, it was dismissed as a calibration error. Space is full of noise, instrumentation drifts. But then a second station, H3SAT-4, located in geosynchronous orbit over the Indian Ocean, confirmed the same thing. An abrupt synchronized loss of helium-3 occurring within the same 10-minute window. The odds of a natural fluctuation this dramatic in two completely different locations were beyond improbable. So the teams did what they always do in moments like this. They checked the solar models. Nothing fit. The Sun hadn't quieted. In fact, it had grown more active, its magnetic field lines snarling like barbed wire across the northern limb. But somehow, the very thing that should have surged with intensity, helium-3 production, was instead being drained, or worse, harvested. That word wasn't said out loud, not at first. But inside the encrypted chat logs of analysts at multiple agencies, the idea began to circulate. The helium-3 hadn't just vanished into vacuum, it had been intercepted, not scattered, not deflected, collected. The possibility sent shockwaves through the teams working quietly behind the scenes. Because if helium-3 was being pulled out of the solar wind in a targeted way, that meant a mechanism existed, a field, a filter or a structure, capable of selecting particles on an atomic scale. Such control would suggest not just advanced physics, but intent. A system that could recognize helium-3 among trillions of other particles and extract it with precision. Not just from one vector, but from multiple regions, near the Earth, near the Moon, and somewhere deep in interplanetary space where the Sun's plasma thins into nothingness. Suddenly all the pieces began to line up, the signal blackout, the energy bursts, the unknown structure at L1, and now, the disappearance of helium-3. It didn't feel random anymore, it felt like a sequence, and in that sequence, the Sun was no longer behaving like a simple star. It was acting more like a reactor, or worse, a source being tapped. Tapped for energy. Tapped for a resource we barely understand. Tapped by something we're not supposed to see. What unsettled scientists the most wasn't just the loss of helium-3. It was the question of where it was going, and what kind of system needed that much of it, that quickly, at that exact moment in time. For the first time in decades, researchers weren't just watching the Sun, they were watching for what might be behind it. By the evening of December 17th, as data from satellites, observatories, and deep space platforms continued to pour in, a new anomaly emerged, not from a new structure or a particle loss, but from something far stranger, a reflection. It came from the Solar Dynamics Array's wide-angle coronagraph, which had been capturing high-contrast imagery of the Sun's corona since the previous morning. In one of the raw, uncompressed image frames, a sharp line appeared across the lower left quadrant, barely visible to the human eye, unless magnified and inverted through thermal filters. At first, scientists thought it was a lens flare, or maybe a residual artifact from cosmic rays hitting the sensor. But when the next several images revealed the same line, shifting ever so slightly, but staying in perfect angular proportion to the solar disk, attention moved from explanation to curiosity, a line that reflects light at those intensities, especially against the chaos of the solar corona would need a surface, a flat one, or at least one capable of producing mirror-like behavior in a wildly energetic environment. No known object, natural or artificial, had ever produced such a clean signature near the Sun before. Comets scatter light. Asteroids tumble. Satellites don't survive at that proximity. This, whatever it was, wasn't just surviving. It was behaving. Over the next 4 hours, researchers tracked the anomaly across multiple instruments, ultraviolet sensors, radio interferometers, even archival imagery from the Solar Terrestrial Observer. The results were consistent. Each camera, each device captured the same reflected signature, but from slightly different angles, as if the object wasn't static but tilting. It was repositioning itself, and the light it reflected wasn't random. It was precise, almost like a signal, bouncing solar radiation back toward Earth in pulses, aligned with the same 33-minute intervals as the earlier magnetic shifts. To reflect light in space is one thing. To control it with that level of consistency, and target it, is something else entirely. At this point, no one was using the term mirror anymore. Internally, researchers began referring to it as a pane, a flat, heat-resistant field of unknown origin, possibly extending over several kilometers, operating near the Sun's equatorial limb. The implications spiraled. A pane that large would not only need to be made of exotic materials, but would also need active positioning systems, thermal shielding, and stability mechanisms beyond anything humanity has ever constructed. This was not an accident of nature. This was intentional orientation on a cosmic scale. Then came the realization that turned confusion into unease. The reflected light was not simply bouncing back toward Earth, it was carrying distortions. Embedded within the return beam were modulations, tiny wavefront ripples like something had passed through a layer of computation before being sent back. And when those modulations were laid across the last known signature of the helium-3 disappearance, they formed a match in frequency. This was not just a reflection, it was a return transmission. But from what? And more importantly, for whom? This chapter was never about just light or plasma or energy loss. It was about the moment we saw ourselves, not in the mirror of space, but in the actions of something else. A system making decisions, sending messages, moving with clear purpose just beyond the reach of our understanding. Something was watching, something was calculating, and for the first time in recorded history, something near the Sun was reflecting us back. The pane vanished by midnight. No trace remained in subsequent images, but its presence shattered one final assumption, that we are alone, even in the domain of our own star. Every chapter in today's story led us deeper into one undeniable truth. Something is happening inside the Sun that no human model accounts for. Not the Parker Solar Probe, not our AI-driven solar simulations, not even our best fusion physics theories can describe the consistency, precision, and velocity of this new solar behavior. This isn't another anomaly, it's a system, a living, breathing process that has rhythm, structure, and, most disturbing of all, intent. 3i Atlas changed the way we look at visitors from deep space. It challenged our assumptions about comets, about object trajectories, and about what artificial motion might look like in the vacuum between stars. But it still existed in our visible skies, in our telescopes, and in the realm of objects we could track. This solar event does not. It hides in light, it speaks in waves, and it acts beneath the surface of the very star that sustains all life on Earth. That makes it invisible, and invisibility at this scale is not just a scientific mystery, it's a planetary vulnerability. Governments are watching, space agencies have stopped commenting. And across research stations from Chile to the Arctic, observatories are quietly rerouting their instruments, not toward 3i Atlas anymore, but back to our Sun. Why? Because this isn't just a question of astronomy. It's a question of survival. If there is something capable of manipulating energy from within the solar layers, something able to bend flare trajectories, delay radiation bursts, or even amplify emissions, then the Earth is no longer a passive observer in this cosmic dance. We are a dependent, tethered to a star whose behavior we no longer fully understand. And when dependence meets unpredictability, you don't get comfort. You get countdowns, you get protocols, quiet ones, the kind that never make it to press briefings but show up in satellite retargeting, unusual high-altitude surveillance flights, and sudden blackout zones in radio frequencies. Something is being prepared for, and if we've learned anything from this solar event, it's that the Sun is no longer a static force in our universe. It may be a player. So what do? We watch, we document, we share. That's why this channel exists, to bring these strange, silent developments into the light, one signal at a time. Because in the face of what might be coming, awareness isn't just a luxury, it's a form of resistance. It It reminds us we're not asleep. It reminds us the story isn't finished. And maybe, just maybe, it gives someone, somewhere, the knowledge they need before the next pulse arrives, before the next anomaly goes silent, before the next light curve collapses, before we lose the signal entirely, because the sun has begun a conversation. And we're just now starting to understand the language. If you're still watching, you're part of the few who are awake. So stay close. New images are coming. And if what we're seeing continues, we may need to rethink the sun altogether. But maybe that's the point. Maybe 3i Atlas didn't come to warn us about something out there. Maybe it came to make us look back at what we thought we understood, back at what we've always taken for granted, back at the one star we orbit, but never truly observe. We've been looking outward for decades, chasing signals, searching the sky, hoping to find intelligence far from home. But what if the first real signal, the first true response, didn't come from a galaxy millions of light years away, but from inside our own sun? Would we be ready to accept that? Would we be ready to ask why? Because if the sun is no longer just burning gas, if it's not just reacting to gravity and fusion, if it's learning, evolving, or responding to something, then every assumption we've built about our place in the cosmos must change. This isn't about fear, it's about focus. We live in an age where information is filtered, distractions are engineered, and truths are often drowned by noise. But here, on this channel, our mission is simple. Cut through that noise, report what's real, and stay ahead of the silence. So if you're still here, if you followed every anomaly, every curve, every unexplained shift, then you understand what's at stake. This isn't a story for everyone. It's for those paying attention, those willing to sit in the uncertainty, those willing to ask what comes next. Because this isn't the end of the signal, it's the start of a pattern, and when that pattern completes, we'll be ready. So stay subscribed, turn on all alerts, and tell us where you're watching from in the comments below. Because next time, we won't be watching the sun, we'll be waiting for its reply. This is 3i Atlas, and this is just the beginning.